Hi guys, we are going to go ahead and do our first bit of notes. If you want, the notes are there on the page for you to print off and you can take notes as we go on, or you can just do this on a piece of notebook paper. It is up to you. But I was going to go through these notes just like we would in class. That way you're familiar with how we do things. Okay, so not much is going to be a whole lot different. You're just not going to be able to see me, but you'll be able to see what I'm going to write on this Smart Notebook file. So what we've been doing is we've been doing similar figures. And if you look on the screen, it basically tells you everything we've been doing right here in this little box. It says two figures are similar, basically if their corresponding angles are congruent, and if their corresponding sides are proportional. So I've always told you you have to check for those two things. If those two things aren't true, then you can't say they're proportional. Well, now what I'm doing today is showing you triangle similarity theorems. Okay, there are a couple of shortcuts that you can use on triangles to tell if they're similar without having to show all three angles congruent and all three sides proportional. And these are going to kind of look similar to some theorems that we've seen in the past. So there's three of them. The first one is, that's the next slide, angle-angle similarity. So for angle-angle similarity, this is the shortcut that says if you have two triangles, as long as you know two angles in one triangle are congruent to two angles in another, then they're automatically similar triangles. So you don't even have to show that the sides are proportional. It's a nice little shortcut. So right over here, that I just made a box around it, it says, let's see if I can write. There we go. It says that if angle A is congruent to angle X, and angle B is congruent to angle Y, well, there you have your two angles congruent to other two angles in the triangle. So boom, they're similar triangles. So then they put the similarity statement. Triangle ABC is similar to triangle XYZ. So then here's an example using angle-angle similarity. Basically, it just says state if they're similar. If so, state how you know, and then do the similarity statement. So when I see these two triangles, I don't see any side lengths given to me, but I do see two angles in this triangle congruent to two angles in the other triangle. So therefore, I can go ahead and say that these are similar triangles. So where it says similar, I'm going to put yes. And then how do I know? I know it because of the angle-angle similarity shortcut, because I don't have to show all three sides and all three angles with this little shortcut. All I have to show is that two angles here are congruent to two angles here. So because they are similar, we're going to fill in the similarity statement. So they call this bigger triangle, triangle JKL. So that means I have to call the other triangle, triangle TUV. So that is angle-angle similarity. It's a nice little shortcut. The next similarity theorem that we have is side-side-side similarity. So I know we've seen side-side-side congruence before. That said, if three sides are equal to three sides of another triangle, then they're congruent. The difference here for side-side-side similarity says not if all three sides equal the other three sides, it's if all three sides are proportional to all three sides. So in this case, all you have to do is you have to show that all three sides here are proportional to all three sides here. You don't even have to bother with showing that the angles are equal to each other. That's how this is a shortcut. You only have to show me that all three sides are proportional to each other. So they give you a nice little kind of formula or a nice little proportionality statement right here. So if we plug in numbers for these right here, we're going to see that they all reduce to the same fraction. So that means they're proportional. So where it says AB over XY, I'm going to put 24 over 12 because I got them from right here. And then equals BC, that's 24 over YZ, which is 12 again, which equals AC, which is right here, 18, over xz, which is 9. And what's nice is this reduces to 2, this reduces to 2, and this reduces to 2. Therefore, I have just shown that all three sides are proportional. So these are similar by side-side-side similarity. Don't have to worry about showing anything about the angles. Okay, so here's a side-side-side similarity example. So when you look, you've got 3 sides listed here and 3 sides listed here. There aren't any angles shown at all. So I probably would not try angle-angle similarity on this. So because I've got the 3 sides here, the 3 sides here, we're going to try side-side-side similarity. So what I would do is I would make 3 sets of fractions and see if they all reduce to the same number. So I'm just going to start with the big triangle and go to the little one. The smallest side on the big triangle is an 87 right here, and that would match with the smallest side on the other triangle if they're similar. Okay, and now the next one, the next biggest would be the 121, and that would match up with the 60. No, it wouldn't. Just kidding. Hold up. That would match up with the 54. There we go. And then lastly, the 132 matches up with the 61 right here. Okay, so I matched up the smallest, I matched up the medium-sized ones, and then I matched up the biggest. So then I would just go to my calculator and see what does 87 over 40 reduce to? Nothing. It doesn't reduce to anything. All right, so it's just 87 over 40. Okay, and then the next one, 121 over 54. So 121, oops, 121 over 54. That doesn't reduce either. It's just 121 over 54. And then I don't even have to bother looking at the next one, because when you look at the next one, not even bother with looking at the next one, because if you look at these two, they don't reduce to the same number, so you might as well just stop. So are they similar? No, they're not. And where it says, how do you know? We could just say, all 3 sides not proportional. I'm running out of room. Okay, and then we don't have to fill this out because they're not similar. So we tried side-side-side similarity, but it didn't work because the 3 sides weren't proportional to the 3 sides over here. Okay, the last one is side angle side similarity. Again, you've seen this before with congruence, but now it has to do with similarity. So congruence said that, I'm going to draw a couple of triangles real quick. This was side angle side congruence. It said if I had one side congruent to one side on another triangle, and then another 2 sides congruent, and if the included angle, remember included angle means the one in between the 2 sides. If that included angle is also congruent, then they're congruent triangles by side angle side. But here's how the similarity one is different. You're still going to be looking at the 2 sides and the included angle, but instead of the sides being congruent to each other, for example, 24 and 24, we want to check to see if they're proportional to each other, meaning this fraction, when you stack 24 over 16, has to be the same as this fraction when you stack 12 over 8. So that is the difference here. So let's go ahead and try, or look at the side angle side theorem. Okay, so this box right here, shows that a little kind of formula. It says if you match AB with AC, just kidding. It says if you, sorry y'all, goodness gracious. I'll get my act together. Give me just a moment. Okay. It says that if you match AB with xy, so 24 over 16, which ends up becoming, you can go over here if you really need it, 24 over 16, 3/2. And if you also match AC with XZ, that's 12 over 8, which also reduces to 3/2. And then this part right here is important. And you know that the included angle, angle A, is congruent to angle X. If this is your scenario where you have two sides proportional to two sides and the included angle is congruent, then these are similar triangles by side angle side similarity. So here's a side angle side similarity example. So here's how I know I'm going to try side angle side with this, even though, I mean, I know you know it because it follows the side angle side slide. But here's how I would know if this was just like a jumbled up worksheet. I have two sides of each triangle labeled, and then if you look here, you've got vertical angles. So you've got two sides and an included angle. So what I would do now is I would check to see, well, are the sides proportional? So what I would do is I would match the 20 with the 32, and then that's going to reduce to give you 5/8. And then I would match up the 25 with the 40. And that also is going to reduce to give you 5/8 because 5 goes into 25 5 times and 5 goes into 40 8 times. So that's good. We've got proportional sides and the included angle is also congruent. So yes, they're similar. We know by the side angle side proportionality theorem or similarity theorem, whichever. And then we've got to fill in the similarity statement. So it says triangle KLM is similar to, well, K on this triangle matches up with K on the other triangle. And then L is going to match up with Q on the other triangle. And then M is going to match up with R. So triangle KQR. So that's your side angle side similarity example. So the next three sides are just jumbled up. They're in no particular order. I just kind of wanted to go through them so you can see how you might decide which theorem that you might use if it was jumbled up. So on the first example here, this to me screams side, side, side because there's three sides labeled here and three sides labeled here. So let's see if they are proportional. So I'm going to match up the 10 with the 50. Those two go together. And that reduces to 1/5. And then the 11 matches with the 55. And that reduces to 1/5. And then lastly, the 13 matches with the 65. And then, excuse my slowness, give me just a minute. And then, yeah, that also reduces to 1/5. 13 goes into 65 5 times. So there we have it. We have all three sides here proportional to all three sides here. So I can go ahead and tell you that they're congruent triangles by using the side, side, side similarity theorem. So I'm going to put yes, comma, side, side, side similarity, comma, and now it says complete the similarity statement. So if you call the top triangle triangle ABC, then you would have to call the bottom triangle, let's see, QRS, I believe. Let's double check that. Q to R. Yes, yep. All right, so the next example, To me, I see, again, 2 sides listed on this one and 2 sides listed on this one. So side, side, side would be out because I would need a third side. And then I also have vertical angles. So it looks like I have 2 sides and an included angle. So what I'm going to try to do is use side angle side. So to do side angle side, the included angle has to be congruent, which it is because they're vertical. And then the 2 sides have to be proportional. So I'm going to say that this 48 matches with the 105. And the reason I picked the 105 is because 48 is the smaller of the two here with 48 and 60, and 105 is the smaller of the two over here between the 105 and the 130. So the smaller one's going to match with the smaller one. So let's see, 48 over 105. That reduces 16 over 35. Okay, so then the other pair that match would be the 60 and the 130. And let's see. So 60 over 130, that's 6 over 13 when it reduces. So these two fractions did not reduce to the same thing, so the sides are not proportional. So even though the angles are congruent here, we don't have proportional sides. So I'm going to say no, these are not similar. Okay, and that moves us on to the last one. On this one, no sides are listed. In fact, hardly anything is labeled on here. All that you see are these 2 arrows, which means parallel. But when I look at this, I go, okay, well, here's another example of vertical angles. So there's one set of angles, so maybe I can find another set of angles to do the angle-angle similarity. Okay, so the reason we're not doing side, side, side or side, angle, side is because we don't have any sides listed anywhere as far as their lengths go. So we've got one pair of congruent angles, and then, guys, these parallel lines tell us a lot. They tell us that alternate interior angles are congruent to each other. So angle L and angle T would be congruent to each other because they're alternate interior. The same thing can be said for angle M and angle S. So you could have picked those instead of L and T, and you still would have had your 2 angles. So right there, I've got my 2 angles, so I'm just going to stop. I'm going to say yes. These are similar triangles by the angle-angle similarity theorem. And then the similarity statement, I'm going to call the top one triangle MLN. And if I call the top one triangle MLN, then I would say M matches with S, and L matches with T, and N matches with N. So I would have to call the other one triangle STN. So that's it. You guys have an assignment with 8 problems. So when you finish the assignment, just upload it. And if you have any questions, just email me and let me know. All right, guys, thanks. Have a great rest of your day.